Kia ora, year 11 and 12. This is part 2 of a really long, rambly video about how we model a curve. I'm going to finish this off now with the exponential, but just a really quick recap. But I strongly recommend that you suffer through the first 15 minutes, which is part 1, the one that I put up about half an hour ago. So what we were looking at in here was this very mucky graph, right, where I just had 2 points and I'm trying to decide how I can model it. Now, I first looked at doing it with a hyperbola, and then we did a square root graph, and now we're on to the exponential. And what you're probably already noticing is that the algebra we need for the exponential is a bit worse than for the other two. But it is going to fit quite nicely, but then so did the hyperbola, and so did the square root graph. So just going back to where we'd got to, we decided that we would model this with an exponential. And we figured out that we thought we were safe to assume that there was a horizontal asymptote at 1. So that meant that the form I had in the first video was y is equal to some base, so b to the power of x plus c plus 1, right? So the plus 1 is because I'm making an assumption about the asymptote. Then I substituted in the 2 points, which are 1, 6, and what was the other one? 3, 2. So I chucked those in and I got 2 simultaneous equations. I got 1 is equal to b to the power of 3 plus c, and 5 is equal to b to the power of 1 plus c. And I did one of these divided by the other, and that gave me 0.2 is equal to b squared. So we got down to b is equal to root of 0.2, and b works out to be roughly 0.447. Okay, so we got that far. Now where I'm up to in here is I'm now going to put that b number in here, and I still have to go through and figure out what c is. Okay, so I'm going to do that on a new screen. So we've got y is equal to 0.447 to the power of x plus c plus 1. Right, I need to use one of the points to work with here. So let's see what I can do. Well, again, we'll use not 6, 1, we'll use 1, 6. So it goes like this. Sorry, brain's going very slowly. 6 is equal to 0.447 to the power of 1 plus c plus 1, which gives me 5 is equal to 0.447 to the power of 1 plus c. Now, I don't know about you, but at this point I'm going, is it really worth using an exponential function when I could have used a hyperbola or a square root with some stretchy factors? Because I'm going, the chances that I muck this up are actually quite high. I'm going to take logs of both sides now, and I'm going to get this 1 plus c log 0.447. Next, I'm going to divide both sides through by this, and I'm going to get log of 5 over log of 0.447 is equal to 1 plus c. So solving that gives me this. Is equal to c. And c works out to be a very nice -3. So let's put all of that together. We've got y is equal to 0.447 to the power of x take away 3 plus 1. Okay, so there's my exponential equation. Remember, this is because I've assumed that we've got a vertical asymptote at 1. Well, that's not the right picture, is it? So let's go back up to here. Now, it's kind of interesting that earlier when I did the hyperbola, I assumed that the horizontal asymptote, was at 0. And here I've somehow jumped to assuming that it's at 1. So it's not going to matter too much as long as you eliminate one of the factors. And so you've just got 2 things left. So 2 points, 2 factors. So this is the final thing, which is pretty cool. So this is how close my approximation gets. The orange line is the correct version. So that's the exact equation, y is equal to 6 over x. But the blue line is my exponential approximation, right? So y is equal to 0.447 x minus 3 plus 1. So pretty cool, right? I've got just 2 points and I found 3 different ways to do that modelling. So the hyperbola picked up exactly this equation, and the exponential was this one here. And you can see it's a little bit too high, right? But it's not too bad. As a percentage error, that's not bad. And then here's the green line here is the square root one that I did in the last video, which is also pretty good. Remember, I'm just interested in it between those 2 points. So just one last thing. Let's just think a little bit about the domain and range in here. So what's the domain? Well, forget about that blue bit there. So the domain between C and D is x between 1 and 3. And the range is what? Well, the range is between 2 and 6. So there you go. If anyone actually has watched all 20 minutes, congratulations. Definitely pineapple lumps if you want to come and collect them from me in M5. I promise I will actually have some in the room in the next week. Thanks for watching.